Drywall's almost up, and that means framing is complete, the electrical rough-in inspection is done, and the HVAC crew got their stuff wrapped up too. And that also means I had to run my network cabling since it's 100 times easier to do when the walls are open. I already have my little network set up in the back with a Wi-Fi access point, but I need high-speed fiber between the rack room and the front office, 10 gig networking in the studio, and a few PoE cameras for security. And that means wires. And the term in construction for network wire is structured cabling. Why not just have electricians install it? Well, they're expensive, and they specialize in high voltage where there are tons of extra safety concerns. Networking is low voltage. That includes any wiring running less than about 50 volts. For low voltage, you don't have to use a licensed electrician, and inspections and standards aren't quite as rigorous, but there are standards. I'm following those on this install, like using this plenum-rated cabling in the open space above the ceiling. In my studio, the plenum is part of the HVAC air return, so cables need to not emit toxic fumes straight into the blower if there's ever a fire. And for cable protection, I did things like use these plastic grommets to pass cable through metal studs so the network cable doesn't short out. Before we get into pulling wire, why have all these cables in the first place? I mean, I have Wi-Fi already, and I can get like 800 megabits since it's Wi-Fi 6, and Wi-Fi 6E or Wi-Fi 7 could go even faster. Well, Wi-Fi is convenient, and it's even good enough for a lot of modern business where you just need to print stuff and stream video calls. But I'm going to be doing video production. I need at least 10 gigabits everywhere because that lets me copy at about a gigabyte per second with almost zero latency. Wired connections can go way faster too. Like these fiber optic lines can get up to 100 gigabits or 12.5 gigabytes per second. And discounting bandwidth, Wi-Fi runs into interference, obstructions, and things completely out of my control, like noisy neighbors. Speaking of neighbors and Wi-Fi, how do you keep yourself safe when you're on public Wi-Fi? Well, for me, when I'm not connecting through my office VPN, I use Surfshark. And that's great because they're sponsoring this video. When I went to the UK to visit Raspberry Pi, I used Surfshark to see some of the content US providers blocked while I tried watching them over there. When I browse the internet on public Wi-Fi and I don't need to access my home VPN, I use Surfshark so nobody can snoop on my traffic. And while I was at the office today, my ISP sent me an email and said my internet was down. I don't trust them much, and if you don't trust your ISP, Surfshark has a guide for putting your whole house on Surfshark using your own router. While it doesn't solve all my networking problems, like pulling Cat6a cable or terminating a fiber line, Surfshark's a handy tool. If you want to use their protection or even some of their other services like Surfshark One with antivirus and data leak alerts, try them for 3 months free with code REDSHIRTJEFF. There's a link in the description. Before we get into the cable install, here's a quick construction update. The electrical rough-in inspection just got passed at the end of August and all the wiring is in place. It'll be nice to have separate light switches for all the rooms instead of having to turn on like a kilowatt of light at the breaker. I also had the electricians put in 2 separate independent ground circuits for the server room, which isn't strictly necessary, but I should explain why. First, that'll give me 40 amps at 120 volts. Some people would go to 240 volts in the server room, but not all the gear I'll be using is rated for that voltage. Higher voltage is more efficient, usually, and you can get more current in the same cabling. But for now at least, I'm going to just have 2 standard 20 amp 120 volt circuits. I'll eventually have 2 UPSs, one on each circuit, and all my servers with redundant power supplies can have one in one UPS and one in the other for dual redundancy all the way back to my electrical panel. And the independent grounds are helpful for some scenarios where I need a clean electrical signal. A lot of times in commercial installs, to save on wire pulls, electricians will share a ground between 2 circuits. The 2014 NEC code actually allows this. Before you comment otherwise, go read section 250.130c.4. But if you want the best electrical signal for precise digital equipment like servers and clocks, having multiple independent ground paths back to the panel is nice to have. There are actually standards for electrical design in data centers, and if you're building more than a tiny rack room like mine, you should probably check out TIA 942. And I had forgotten this in the plans, but I also had them install one more outlet on a dedicated circuit over here for a fridge and microwave. Technically, you'd want 2 circuits, since if a fridge kicks in while the microwave's running, it could trip the breaker, but I'll have a pretty small fridge and microwave, so hopefully that won't be an issue. And I noticed the electrician was using electrical boxes that rely on pressure on the opposing drywall for stability, but without any neoprene there, the box could actually transmit sound through the wall, so I put some rubber behind the standoffs. For HVAC, instead of routing the ducts horizontally on the front and back walls, the HVAC guys put in 3 of these 90-degree elbows with lining inside to deaden any sound transmission. That should be enough, but as I said before, the ceiling is really the tough part of this whole studio setup. The HVAC system can be a little loud and squeaky, though it goes to a pretty standard hum once it's running, like this. Hopefully those 90s, along with the flex duct, is enough to stop any extra sound getting into the studio. Alright, it's time to talk structured cabling. Now, this isn't going to be some massive install like this picture shows with hundreds of cable runs, but even so, it's good to do things right and to have a good plan heading into any networking project. Especially before they close up the walls, I had to make sure to consider the way I'm going to use this space and run all the home runs, the runs back to the main server closet, before that happens. There are some cool tools like these pulleys to help run bundles of wire through a space like this once it's all built out, but it's always easier to do things while it's all gutted and open. And before you start pulling wire, you actually have to have the wire to pull. Is copper-clad aluminum okay? What's the difference between UTP and STP? Is it okay to buy cheaper wire, or is plenum rating better? This video is not diving that deep, but at least for my office or something like it, you should know the difference between plenum and riser cable when you buy in bulk for an install. Plenum cable goes in plenum spaces, and riser cable goes most everywhere else. What's a plenum? It's that area, up above the ceiling tiles. In many commercial buildings, the space above the drop ceiling is used as a giant return air duct for the space. That airflow delivers tons of fresh oxygen. Plenum cable has a jacket on it made of PVC or FEP, which are basically less flammable and emit less toxic fumes if they do catch fire. They're not fireproof, they're just doing a little extra to help reduce the loss of life in case of a fire by delaying its spread and reducing the number of harmful toxins. Not all ceiling spaces are plenums. There could be ducted returns. But my space is, so I have to use plenum-rated cables. The two fiber lines I'm running are also both plenum-rated and cost a little over $50 each. And this monoprice cable is also Cat6a plenum, which also cost a pretty penny. For any runs that only go in the wall or for patch cables, you're free to use riser, which is a bit cheaper. Outside of the plenum rating, it's good to get pure copper wire. It costs a little more, but you'll get a better signal, especially over long distances. Solid core is better for an install than stranded, but patch cables use stranded since they're more flexible. And for Ethernet cable, shielding is useful in environments where there might be more electrical noise, RF, or power lines. Cat5 and Cat5e are good for gigabit networks, and in most cases 2.5 gigs, but if you want 10 gigs, or if you want to run PoE++ for fast Wi-Fi 7 access points, you should use Cat6a. The wire diameter is bigger, and there's a fun little separator that keeps the twisted pairs apart for less crosstalk. For fiber, well, fiber can get even more complicated, and unless you have expensive fiber termination equipment, you kinda have to buy pre-terminated cables in the length you need. I bought OM4 multimode fiber cable with LC connections because that works with the 10 gig fiber transceivers I'll be using. But fiber has its own mess of acronyms, like OFNP to indicate it's plenum rated, and there are different ratings for different wavelengths of light. The main point here is to do your research. Make sure you use the right cabling and connections, otherwise you might have to re-pull wires, and pulling wires ain't fun. There are a few types of pull strings, like more rigid fish tape and nylon pull cord. In this case, we're using Power Fish pull line. It basically helps pull multiple cables at once without the line breaking. To get the cables up from the server room to the front office, I installed some bridle rings on beam clamps. These things are pretty easy to get onto roof structure, and they'll hold the bundle of wires up above the ceiling and out of the insulation. I won't show it, but we also pulled an extra pull string later in case we want to run another wire after drywall's up. If you don't do that, running wires after the fact with some cable pulleys isn't too hard, it's just a lot more annoying. A new trick I've tried on this job was using a ladder and rigid conduit to hold the cable spool. There are spool holders for this, but the good ones cost like $50 to $100. If you have a ladder and conduit laying around, just use that and save the money. I mean, if you do enough cable pulling, it would be worth it, but this worked out really well in this job. It's just literally a $4 piece of pipe stuck in a ladder. Since we wanted to get the fiber and Cat6a runs all done at the same time, we pulled them all together. I'm glad my dad was helping because it takes a lot longer to pull cable alone. Also, with these fiber cables costing $50 a pop, it's nice to have someone guiding everything in so you don't get one knotted up and broken. Anyway, we got everything taped together on the pull line with each cable getting taped in an inch or so back from each other, so it forms a wedge shape that's easier to maneuver into the little guides. And here we are starting the cable pull. The first loop is really the most important. You want to make sure you have all the cables going in smooth without them tangling up. It's really bad if you're halfway through the pull and you've got to pull it all back out. I pulled from the front office and my dad was guiding the cables off the spools at the other end. My nephew, thank you very much for coming and helping us, was filming this, so that meant we could focus on the pull. My dad let me know when you hit the end of the run, and we headed over to the second cable pull over to the workshop wall in the studio. I ran a couple Cat6a connections that way, and I'll probably have a switch over there for the work tables. Going into the walls here, metal studs are sharp, so you really need these cable grommets if you're going to pass through any wire horizontally. They just pop in, and they're really easy to do. Then for the top, typically you'd have a grommet here where I'm drilling with the step bit, but in my case, since we had this neoprene rubber in place already, I just let it kind of hold the wires in place. This is low voltage wiring, so it's not going to fail inspection, but it is better to use a grommet, especially if you don't have rubber holding the wire centered like I did. Also, when you drill upward into metal, the hot metal shavings fall down, and if you're not wearing gloves, you'll definitely feel it, so that's fun. As I'm pulling everything through, you'll notice I also marked the cables with different tape patterns, like 2 black lines or 2 blue lines, just a quick way to label the wires so I wouldn't have to recheck them all later. To hold the cables vertically, I'm using these Colorado Gym cable supports. I saw the electrician using them for his pulls and they seemed to be really fast and secure, so I went with it. For the network jacks, I just used plastic Newark boxes meant for low voltage cabling. To make sure that I can get to the cable after the drywall's up, I looped it over itself and tied it off with some Velcro. I should be able to reach in and yank out the cable. And I decided to pull another jack for the front wall of the studio too. That'll be for my main recording area. I might put a switch in there or something too, depending on what kind of testing or live stuff I'll do. Right before they finished the walls, I pulled 2 more cables by myself up to the front office. Someone commented it's better to have more runs and not need them than to wish you'd pull more when everything was open. And I like that advice. What other ideas do you have? Leave them down in the comments. I don't know exactly where my desk will go or anything else in the office space, so my plan for now is to just leave those cables hanging up in the ceiling. Speaking of cables in the ceiling, now there's quite a bundle up above the rack room. And look at that, drywalling's almost done too. The guys got moving on insulation, then drywall, and this week they're going to work on tape and mud. Hopefully by the end of this month we'll get to finishing work, but we'll see. Subscribe so you don't miss any of it, and until next time, I'm Jeff Geerling.